Hello everyone, my name is Ratna Prakeen and my project is predicting Telecom Customer Churn, an AI assisted value based retention strategy. I will show how a free AI tool helped frame the business problem, generate and check an analytics workflow, and communicate the result. The central idea is that a useful churn product should do more than predict who might leave. It should tell a manager whom to contact, how much capacity that requires, and whether the expected return justifies the effort. Now, the business context and objective. Telecommunications is a subscription business, so cancellations directly reduce recurring revenues. Replacing a lost subscriber also requires acquiring acquisition spending. While retention teams have limited time and budget, the decision I focused on was which customers should receive proactive retention outreach. The objective was to rank customers by churn risk and then choose a contact threshold that maximizes the expected net value. The IBM sample contains 7,043 customers and 19 usable predictors. About 26.5% churned. I evaluated the project using both analytical and managerial measures, ROC, AUC, and recall for predictive quality, plus contact volume, expected net value, and return on investment for the decision. Now, why ChatGPT free? I selected ChatGPT free because it has $0 entry point and currently offers limited file upload and data analysis capabilities. It is useful as a conversational bridge between a business question and a technical analysis. I use it to structure the problem, draft Python steps, identify quality checks and challenge assumptions, and translate outputs into business language. In the demonstration, I show one uh, prompt. I ask for the leakage safe train test workflow and explicitly tell the model not to invent results. The response outlines the pre-processing pipeline and metrics, which I then compared with the final analysis files. This illustrates an effective prompting practice, provide the business purpose, requires methods, constraints, and verification standard. The important control is that I did not accept numerical claims just because the AI produced them. I executed the code, saved every output, checked the primary data source, and recalculated the metrics. ChatGPT assisted the workflow, it did not replace the verification or managerial judgment. Now, data and reproducible workflow. The data came from IBM's public telco customer churn repository. It includes demographics, contract type, internet service, add-on services, payment method, tenure, and charges. I converted total charge from text to numeric. 11 blank values were inputted inside the pipeline, so information from the test set did not leak into training. Customer ID was removed because it identifies a records rather than a behavior. I used the stratified 75 to 25 split, 5282 rows for training and 1761 unseen rows for testing. Numeric variables were standardized, categorical variables were one hot coded, and I compared logistic regression with random forest. The same pre-processing was fitted on the training data from both models, making the comparison consistent. I also fixed the random seed on the split and results are reproducible. Finally, I evaluated many probability cutoff using explicit retentive economics, refit the selected module on all labeled records, and produced a second customer file with risk band and recommended contact flag. Now, descriptive finding where churn is concentrated. The segment analysis shows where churn is concentrated. Month-to-month customers churn at 42.7% compared with 11.3% for 1 year contracts and only 2.8% for 2 year contracts. The tenure pattern is similarly strong. Customers in their first 12 months churned at 47.4% versus 9.5% after 49 months. Other high risk groups included fiber optic customers at 41.9% and electronic check users at 45.3%. These patterns suggest practical hypothesis, strengthen onboarding, test contract conversion incentive, investigate fiber experience and values, and reduce payment friction. However, these are overlapping associations. They do not prove that changing any single field will change uh, churn to fall. So the recommendations must be tested experimentally. Module performance. Logistic regression achieved an ROC AUC of 8.846 on unseen data, slightly above the random forest at 0.844. An AOC of 846 means that the module has useful ranking ability across thresholds. At the usual zero point 0.5 threshold, recall was 79.7%, precision was 52%, and accuracy was 75.1%. I selected logistic regression because its ranking was marginally stronger and its directional signals were easier to explain. I did not choose a final cutoff using accuracy because false positives and false negatives have different business consequences. The next step connects the probability score to the actual retention decision. Business value threshold. The economics chooses a 0.13 cutoff. For an illustrative scenario, I assumed each contact costs $10, a successive save trigger a $50 of offer cost, outreach saves 70% of contacted churners, retainers value last 12 months, and contribution margin is 50%. I calculated the expected net value at cutoff from zero point 0.1 through 0.9. The best tested cutoff was 0.13. It contacts 73.1% of the test population, but reaches 78.9% of actual churners. Expected test set value was $41,426 with a 209% ROI. Contacting everyone reaches only 5 additional churners but costs more, producing $37,153 and 151% ROI. A random same volume strategy also produced substantially less expected value. The curve is fairly flat near its peak, so managers could choose a nearby cutoff if weekly capacity is tighter without sacrificing much scenario value. Scaling the health out scenario to all 7,043 customers suggests approximately $17,100 more value than contacting everyone. This is a scenario, not a forecast. Actual pilot results should replace the assumed safe rate and cost. Recommendations. I recommend a controlled retention pilot. First, create a weekly queue ordered by predicted churn probability and apply the 0.13 threshold as the starting capacity rule. Second, prioritize early tenure month to month customers but tailor the intervention rather than sending the same offer to everyone. Test a contract incentive, a proactive fiber service check, and an autopay message. Third, keep a randomized no contact control group. That is essential for estimating whether outreach cost incremental retention rather than merely contacting people who would have stayed. Finally, monitor realized net value, contact rate, offer uptake, incremental save rate, customer complaints, fairness across segments, and model drift. Recalibrate the threshold when economics or capacity change. AI value and limitations. ChatGPT added value by accelerating the earlier thinking, scaffolding code, suggesting quality controls, and helping convert statistical results into a concise business story. The conversation also make it easy to revise the objective from maximizing accuracy to maximizing expected value. That saved iteration time, but it did not establish that the answer was correct. Generative AI can produce code that runs while answering the wrong question, invent citation, and overstate casual conclusions. Conclusions or overlook leakage and privacy risk. Free tier usage limits can interrupt analysis, and uploading real customer data would require governance approval. My controls were to use public data, execute and inspect the code, preserve a test set, check primary sources, label assumptions, and treat the final decision as human owned. I also preserve the prompt log so another reviewer can see how AI influenced the work. Production use would require fairness testing, calibration, time based validation, secure data handling, and clear accountability for adverse customer impact. Conclusion, the final takeaway. In conclusion, the model produced useful churn ranking with an AOC of 0.846, but the real contribution is the decision framework. A 0.13 pilot threshold captures nearly all observed churners while reducing contact compared with an everyone strategy, and the scenario suggests about $17,100 in incremental value. The next step is not blind deployment, it is a controlled experiment that measures two incremental saves and updated the economics. The takeaway is simple: prediction creates a score, economics and experimentation create business value. Thank you.